here we are, day 10, last day of notes in the statistics unit. Surveys, experiments, and observational studies. So, statistical research takes various forms depending on whether the purpose of the research is 1, a survey, which simply measures variables. 2, an observational study, attempts to find an association between variables, a connection. 3, an experiment, which attempts to establish a cause and effect relationship between variables. So notice the difference between 2 and 3. Observational is just trying to see if there's an association, but 3, experiment, is trying to find cause and effect. So, a survey measures a characteristic of interest from a population using a sample selected from a population. Now remember, way back at the beginning, are different possible sampling techniques. Self-selected or voluntary. That's like, principal sends out a survey to all the students. Whoever decides to participate, participates. A cable TV company sends out a survey to all their customers. Whoever decides to participate, participates. Again, remember, those are often biased, because usually only people who are strongly feeling one way or the other, positive or negative, do that. A cluster sample. Remember, a cluster sample is often based geographically. It often is confused with a stratified sample. So a cluster sample is maybe voting areas, voting districts, zip code, attendance area for elementary schools. Even in the school, homerooms or classroom would be cluster samples. Okay, as opposed to stratified, let's get down. Stratified is when you separate into groups like freshmen, sophomore, junior, seniors, male, female, whatever. If you think about it, for cluster, one class first hour, the next hour, different people in the room, different mixtures. But if I said freshmen, sophomore, junior, seniors, that's not going to change throughout the day or even throughout the year. Okay? Another difference is with a cluster sample, I don't have to randomly choose from every sample. I could only choose some of them. So I wouldn't have to choose from every classroom randomly, just some of them, or some homerooms. Whereas with stratified, you divide them up freshman, sophomore, junior, senior, and you randomly sample from each one. Now, if I only sampled from the freshmen, or just from the seniors, that would make that what start off with a stratified sample into a cluster sample because I was only choosing some groups. Now remember, the cluster sample, you can do all the groups or some of them. Convenience sample is just what's there. So I'm just going to ask everybody as they're walking into the library or walking into school or who's at lunch this hour. Just convenient based on who shows up. Okay? The more random you have, the less bias you have, and more valid they are. So stratified we talked about. Systematic random sample is names in a hat. Computer-generated random list from a master list. And a simple random sample is generally the best method to choose. Okay. Now, on an observational study. Researchers observe whether an existing condition is a characteristic of interest. An observational study can only establish an association between a factor and a characteristic, not causation. And an experiment, researchers impose a treatment on the subject. Experiments can be used to show cause-effect. Now we have two groups here. We have the treatment group and we have the control group. The treatment group is given the treatment. And the control group is not. They don't receive the treatment. Okay? So a lot of times it's done with medication, and you have the treatment group is given the medicine, and the control group is given a placebo or a sugar pill, and see if it really has an effect. Okay, examples. A researcher, explain whether it's an experiment or an observational study. Researcher wants to know if a soil additive makes a fern grow more quickly. He grows one specimen in treated soil and one in untreated soil. Well, first off, right off the bat, when it says wants to know if this makes a difference, if it makes a difference, What makes it grow more? You know you're trying to prove cause and effect. So right there, you know it's an experiment. Now, beyond that, if you have one with treated and one with untreated, again, that's your treatment group and your control group. Number 2, to find out whether accidents are more likely on rainy days, a researcher records the weather conditions during 50 randomly selected accidents for the past year. Okay, so this one, when they're just looking back at data, okay, that's already happened, that's observational. Now you might say, well, wait, aren't you looking to see if the rain caused the accidents? Well, yes, you are, but you're looking back over data that's already happened. You didn't divide them up into a control group and a treatment group. Okay? Not that this would ever happen, but for something like this, you'd have to have like rain machines on one side of a road and not on the other, and then spray the road and see what happens. That would actually be an experiment. It'd be unethical, I would assume, to most people, but that would be an experimental version of this. But looking back over data that's already been found is observational. Okay. Survey, observational study, or experiment. Random sample of 100 households. 62 have at least 2 cars. That would be a survey. You just send out a survey and say, hey, how many of you have 2 cars? Number 2, in a group of 120 patients with cancerous tumors, 60 are given a new treatment and 60 are given the traditional treatment. After 6 months, the tumors are remeasured. Well, in this fact, you're doing an experiment. You're experimenting between 2 different medicines. So it doesn't always have to be a medicine and a placebo. It could be 2 different medications. 3, a study reports that college students who have taken physics in high school are more likely to pass college science courses. Again, you're just looking back at data that's already occurred, so you're observing. This is observational. You're just looking over old data. In a sample of 250 former athletes, 56 became coaches in their sport. Well, this is like the first one where you just ask them and you can survey and get that information. Number 5, a study reports that girls who play with blocks when they're younger are more likely to be good at math and science. So since you're just looking back at the information, that would be observational. And that's it. Short notes.